then if you add 1, then this is congruent to no prime. This is not divisible by any prime, because of course this is going to go to 0 if you mod it by any prime, because it's a multiple of every prime. Then you add 1, and 1 is never going to be congruent to 0. Right. So that means that this is never going to be divisible by any prime, so that means it must be a new prime. But that means it's...
I have one question. So why this number has a divisor?
Sorry?
You wrote this number, no?
Yes.
2 multiplied by 3 multiplied by 3 and then you add 1, right? So why this number has a divisor?
Has
a divisor factor.
Oh.
You claim that in this number has no prime factor among this, right?
Yes.
But why this number has a prime factor?
It has. Well, technically, it's prime factors itself. No.
Sorry.
Are you asking me why it had no prime?
Right. See. Just give me the chalk. See, you start with 2, 3. If the number of primes are finite, so you assume that this is the complete set of primes, right?
Yes.
Then what you wrote here, you construct a new number, right? Sorry.
So you were asking me why this is a prime?
Yeah. So I call this number as Q, right?
Yes.
Then what you said that this is actually this number not equivalent to 0 mod P, right?
Yeah.
And this, what is that at this P?
P is can
right.
be any.
P belongs to?
Yes.
2, 3. Okay, this, right?
Yeah.
From this, right?
Yeah.
So my question is that why this Q has at least one prime factor? You said now that this number has no prime factor from this, right? So my question is why this number has a prime factor? So let me write it. Why Q has a prime factor?
Q. Oh, okay.
Right?
Okay.
If Q has a prime factor, then you will justify whether that prime factor is belongs to this set or not, right?
Okay.
So first of all, I have to ensure that this number has a prime factor, right?
Yes.
Why?
But because if it doesn't have a prime factor, it can only be 1.
Then what will happen? If this number has no prime factor, then what will happen?
Then it has to be 1, right? Because
right.
Yes.
Then
so this this has 1 prime factor. It's itself.
What do you see?
Integrals, infinite series.
Imagine if we could look so closely, we could see each grain, each particle. You see, there are patterns in everything.
Integrals, infinite series.
I've never seen anything like them. From an Indian clerk.
You see, there are patterns in everything.